another 6 Caillou challenge called Simple Fun number 56, Beautiful Text. Your task, consider a string containing only letters and white spaces. It is allowed to replace some white spaces with new line symbols to obtain a multi-line text. So I'm not going to read this whole thing to you as usual. I know you know how to read. But go shoot down to the example down here and you can get an idea of what a beautiful text is. Notice how there's a way to insert new line characters to make it such that each line has exactly the same length. Notice these lines are all ending in letters, they're not ending on spaces, and it comes to an end at the same point. That's the idea, but you don't have to do this for every value. They'll give you an L and an R, a sort of left and right, a low value and a high value, to see at what point. So like if L is 4, it would be 0, 1, 2, 3, 4, cut right after look, of where you could potentially start to look for line lengths that could result in a beautiful text if you insert them at every 4th character. For example, if L equals 4, L equals 5, etc., you're doing it every 5 characters. So they gave you one that's true. This string S, notice it just looks like one sentence here all on one line. But you can replace the 13th and 26th characters with the new line character and obtain the following multi-line text of width 12. They go on to give you another example for S, A, B, C, D, E, F. Output should be false, and they tell you why. It would work for 3, but 3 is out of the bounds, right? 3 is less than 4. And 11 would work if you put it all in one line, but that's outside the high bounds of 10. So hopefully that's clear. Take all the time you need to read to understand the problem. Notice some constraints here. They're not getting crazy with the input size or the values of L and R either, so that's good. Anyways, you know what to do here. Pause the video, have a go, come on back when you're ready. So I'll go into a solution. I'm just going to sort of not try for anything fancy or overly condensed, but I'm just going to try to show you a way how we could think about this problem in sort of real life or an object-oriented way and come up with something, So we'll get rid of the comment. My idea then is I'm going to sort of take the input string S here and I'm going to split it into a collection of words. And then the idea is I'll make some kind of for loop, right, that will start at the lower bound and proceed through to the upper bound. And the idea is I'm going to want to try to inject new lines at each point to see if the result comes out as a beautiful text. And the way I'll do that is as I'm looping, I'll sort of pull words out of my collection in order, and I'll ensure, I'll build lines up to the current length, whatever L happens to be to start, and then I'll proceed and make another line and keep pulling words out of my collection until I'm all the way through the input string. And then at the end, we'll sort of look at all these lines that we built. We'll be adding them to a list, and then we'll ensure that the list, each line in the list has the same length. And that's sort of how I want to view a text as beautiful. So to that end, first things first, I'm going to make an array of string called words, and I'm going to say S split. You know the split function. If you provide it null, I think you can also just leave it empty and it should just split on white space, which is what I want to do. I just want to know the words in the string to start. So let's look at this first example down here. Look at this example of a correct text. Okay, so it'll contain 1, 2, 3, 4, 5, 6, 7, 8 words, right? You could run this and print out the length if you don't believe me. It's just going to have 8 words with no white space included in them. That's what I want to start here. And so then, like I said, we're going to have some kind of for loop. I'm going to say int I equals L to start our lower bound, while I is less than, I'll say less than or equal to R. We're going to include R in our processing, and we're going to increment I each time. Good. So we're going to check each one. And the idea is that we can break early, right? If we find beautiful text for I equals L, the very first value, or the second or third, we can just say, hey, it's true, because there exists a value. The whole function should return true, right? We don't need to continue processing if we know the result's going to be true. So that's good. And then to sort of achieve this idea where I'm going to have a collection of words and sort of pull them out one at a time, I want to use a structure called a queue. If you haven't been with me long enough to see me use this structure before, it's what we call a FIFO structure, a first in, first out, as opposed to a stack, which is a LIFO structure, where you get the last word out first. So a queue is just like the supermarket line, right? Whoever is at the front gets served first, and then the second person is second, just like what you would think. I'll call it queue equals new queue of type string, right? I'm going to load the words in here. And the constructor's nice here. You can look that up, but I can just put words in here, and it will take my array of strings and basically transform it into a queue. So it's nice that they have a constructor that does that. Good. So we got this queue of words that I can just pull out of. And then I told you I'm going to sort of maintain a list of lines. So each time we process a line, I'm going to keep it, because at the end I want to check that all lines are the same length. So I'm sorry, list of string. And I'll call it lines. I'll say new list of string. Good. So we've initialized that. We can work with that. So the idea then is that we need to process through all of the words in the queue, right? So I'm going to do a while loop for this. This is nice when I just have a collection and I want to go through it till it's done. So I'm going to say while queue.count is greater than 0, that would mean the queue still has an item in it, right? We need to keep processing while there's a word. We can't just stop early and say beautiful text and be done, right? It's got to happen for the whole input. So we're going to go all the way through that. I'm just going to make a local variable here called line. And the idea is that we're going to construct this and then add it to the lines list when it's built up properly. Okay. And so then the idea is that while this line is less than whatever index value we're processing, so in this example, we'll just use this to give something concrete, 5, right? We're going to start with the L is going to be 5 first. It's going to get assigned to I. So I want to check while line, which is nothing right now, it has 0 characters in it, while it's less than 5, I need to keep pulling words from the queue, right? So we'll say while line.length, remember strings have a length property, is less than I. And then don't forget too, we also, as we get through this, the queue's going to keep losing words. We're going to keep pulling words out of it until we get to the end. So I just want to remember to say, and while the queue count is greater than 0, just that we have another word that we can pull, right? So while that is the case, let's say string word, this will just be the next word, will be the queue, and then it has a function called dequeue that you can look up. It just pulls a word out of the queue. It removes it from the collection. So the count of queue went down by 1 when I did this too. And I got the actual value that was at the front. And then the second value is now at the front. So good. And then I'm going to check, because you can imagine as we do this one time, we're going to get a word. But the second time we come through this, say I was a long value, right? It may encompass more than one word. So we just want to make sure that word isn't empty at this point. If it is, we want to add that space because there are spaces between words, right? So if string is null or empty, and notice if you didn't catch it, I put the little bang operator in there, the exclamation mark, and that's just, we know that's just a negation. So I'm saying if line, the argument I pass is not null or empty, right? That means word is something. It's no longer, line is something. It's not the empty string anymore. Then we want to add that space, right? So I'm just going to say line plus equals a space, just to put that space between the words. Good. And then we're going to add our new word to the line, right? It could be one word for a line. It could be multiple words. And again, I encourage you, if you want, you can write print statements in here just to kind of see how this works. You can say console write line. Maybe you want to see what the word was. Removed from queue. And insert these wherever. You just, it'll paint a picture for you to see how this thing is processing. Okay, so good. It's going to build up a line of at least length I, right? It could go over, so, but we'll handle that. But the idea is we'll get the sufficient size, and then we're going to say lines add line to our collection. And that's good. Then we can say, we can check to see if that line violated. Remember, it's got to come out exactly to this I value in length, right? Otherwise, it's not pretty. If it's one character over, it's just, they're not all going to line up straight. So that would be considered a violation. So I could say if line.length is not equal to I, then we can just be done, right? We don't need to keep processing. Again, it was sort of that idea, if we know the whole function returns true, don't keep processing. We don't need to keep incrementing I, right? We know the final value is true if even one value works. So again, I'm just trying to cut out some undue processing if that's the case. Okay, and then assuming that's not the case, we can clear the line for the next round. We want to start over each time with an empty line, right? You don't want to keep building on the previous line. Hopefully that's clear. Again, add your console write line statements if you need to see more of this in action. Good. And then, so finally, like I said, at the end, we want to sort of do this. Maybe I should expand this. Uh-oh, what did I do here? Where's my code? Oh, I see, I expanded the tests. Expand this, okay. So where's our while loop? This closes our while loop. So after that, right, after the while loop, I want to sort of check. This represents the case that all the words have been spent, right? We loaded up our split words into the queue. We went through this while loop until it had values, and then once you're out of it, that means the queue's empty. We've done every word. So now we do that check to make sure every line in our lines collection is the same length, i.e. it's pretty. So I'll say lines all, this is a link function, okay? And it just checks that all items in this collection meet some property or fulfill some predicate that I'll answer here. We're going to use a lambda function here. Remember, as a lambda, I have a single parameter here. I'm going to name mine line to represent each line in lines, but you could name it whatever you wanted to. Then we include the arrow, and then we go on to the body of this anonymous function. So we'll say, quite simply, line length, we get to reference the variable we set up. If the length, we want to make sure it's equal to I, right? The number that we were checking for. And if that's the case, we can simply return true for the whole function. We could say we're done. Like I said, we might get lucky and find this on the first value. That's great. And then the idea is, of course, that if we get through our entire for loop, this closes our for loop. You can see, wait, where's our for loop? That one closes our for loop. Let me go back. Closes our for loop. And if that happens, we've processed from L to R. We've done all the checks that we're allowed to do. And if nothing was able to return true, then it's false. Something like this should get us there. So let me go back and test. I'm probably going to get yelled at for not using some using statements that we need to bring link in. And we need to bring, look at it, it doesn't know what queue is, it doesn't know what list is. Hopefully you've seen enough of these, you're starting to remember. It should be using system collections generic for those two types. I'll do just that one first. So hopefully we'll see those collection errors go away, those types. Okay, good. List does not contain a definition for all. Remember I said all was a link method. So let's bring in using system link. Hopefully that gets rid of that. There you go, green. But we don't claim victory until we hit the whole suite. Let's run an attempt. Let's see if we still, good, we're golden. The variable pass the sign with its value is no reuse. You can certainly fix that if you want on line 108. Actually, I don't even know if that's mine. I'm not going to worry about that, but I will remove the output. But if you did want to see this, remember you can expand these. And notice my print statement: word removed from the queue, look was removed from the queue, at was removed from the queue. And then look and at, you know, you can kind of get an idea of how this goes. Remember, those console write lines can save you a lot of heartache. In a normal IDE, you can step through it. It's not such a big deal. It's actually nicer to work with than having to print this information out. You can sort of step through the program. But this is what we have here working on Code Wars. So yeah, I'm sure we're going to see much cooler answers when I submit. But the idea, I just wanted to get you a way to start thinking about thinking about problems, thinking about it in terms of actual objects. You know, I kind of thought of it like I have a pile of words here, right? And I'm arranging them in order in a queue. And I've got this other little pile on the side where I'm going to sort of build lines out of the words up to a certain length. And then I was going to check that each line was the same length. And if it is, I'd say, yep, we got it. And if I go through everything from L to R and don't find that, I'm finally going to just return false. We went through the entire span. So, yeah, like I said, I'll get rid of this print statement. Good. They'll probably make me run it again because I changed the code. And then we should get that green submit button, which I'll get. I'll go ahead and fire this off. And yeah, there you go. Feel free to look through other people's answers, see if you can get something cool from them. Maybe you haven't seen string split options, remove empty entries. Yeah, plenty of stuff to chew on there. Otherwise, you know where to find me. Hit me up with your questions. As usual, I really appreciate the likes and subs, and I will see you in another video. Thank you.